At first glance, question 7 looks fairly straightforward, but it's got a bit of a sting in the tail. So let's just have a look at this. We're told that a particle moves in a straight line. Its velocity after t seconds is given by this function here for values of t between 0 and 2. We're told that after p seconds, the particle is 2 meters from its initial position, and we're asked to find the possible values of p. So, we should be able to recognize that the displacement is going to be equal to the integral of velocity with respect to time. So we can calculate the integral of the velocity function, which we've got here, which is 6t minus 6. And we want to do that between p seconds and the time 0. So we'd here work out the difference in displacement between 0 and p, which we know is going to be 2 meters, or we know it's 2 meters from its initial position. So if we integrate this with respect to t, we're going to end up with 3t squared minus 6t, and we're going to look between the intervals of p and 0. Now, if we take the displacement to equal 2 meters, so we've inferred that from the question. It says there's the particle 2 meters from its initial position. We can substitute in, so for our upper boundary here, we know that t is going to be p, so this is going to be 3p squared minus 6 times p, and obviously if we substitute in for 0, that would just be 0. So we can set that equal to 2. So we end up with a quadratic 3p squared minus p minus 2 equals 0. Now if you solve that using your GDC, you get a value of p equal to 2.29 using the quadratic solver. However, we are told that the values of time we're interested in here, or the domain for the time is between 0 and 2, so this is not a valid solution. So we must have missed something. The only other possible solution here is that our inference that the displacement is 2 is not necessarily true. All we're told is that the particle is 2 meters from its initial position. So at this point here, it could actually be negative 2 meters. So it could be 2 meters in the other direction in terms of the displacement. So we could end up with negative 2 here equals 3p squared minus p, or a quadratic in which 3p squared minus p plus 2 equals 0. Now, if you solve that using the GDC, you end up with a value of p equals 0.42 or 1.58. So those are the possible values of p.